When you're developing an app, security might be treated as an afterthought. With functionality requirements and tight deadlines, it's easy to accidentally write vulnerable code or use a vulnerable dependency. But Snyk can help you secure your code in real time, so you don't need to slow down to build securely. Develop fast, stay secure. Good developer. Snyk.
Hello and welcome to another episode of Virtual Coffee with Ashish, also known as the Cloud Security Podcast. And today's topic is continuation of the Kubernetes Security Month, which we have been running for the month of October. The first topic last week was with Jimmy Messer. We spoke about what is the best practice for running Kubernetes and how can you actually do it the right way. Today, we're kind of taking in a different direction. Software signing and software supply chain has been a topic which has come up quite often. And as we kind of do these episodes on kind of towards the KubeCon coming up in a few weeks for North America, I've got a special guest here. We're going to talk about software signing and what does it really mean by software supply chain in the Kubernetes context. For this, I need to put the intro music first on, so let's do that. Hey, Luke, welcome.
Hey,
thanks for coming on the show.
Hey, Ashish, good to be here. Thank you.
Oh my God, thank you so much. And I've got a few people coming online as well. Hey, Vinny, thanks for coming in, man. So to kick it off, I think I would be surprised if people don't know you in the Kubernetes space, but for the 2 or 3 people who don't know you in that space, tell us a bit about yourself and how you got to where you are today professionally.
Yeah, sure. So I've been around open source for quite a while, predominantly security, and been part of many different communities over the years. Originally started in something called OpenStack, which was another sort of cloud type orchestration platform. Did security there for a while, done stuff around the Linux kernel, different parts of the ecosystem. And I got involved with Kubernetes, I guess, 3 to 4 years ago, I believe. And what I currently do is several gigs really that I have. So I'm part of the Kubernetes security response team. Okay. So we're a group of folks that what we do is Kubernetes has something called a bug bounty program. So if somebody finds a security risk, a vulnerability, they can report it to this bug bounty program. And then if it proves to be, of a possible exploit, something that's of risk to Kubernetes users, they get a financial, they'll get some money essentially. There'll be some cash that's given to them. And what we do is in the security response team, we sort of triage these security issues as they come in. So we look at, is this actually exploitable? Mm-hmm. Is this a real risk? And then if it is, we start to talk to developers and try to sort of work out a code fix and work with release management. The other stuff I do is SigStore, which has got quite a lot of attention recently. That's a big part of the Kubernetes ecosystem. And I have my sort of job, so to say, is at Red Hat. And there we do a lot of upstream work in various types of security areas mostly around cloud native. So yeah, that's generally sort of cloud native, but a lot of stuff around hardware trust as well.
And SigStore is the reason why I definitely wanted you to come on the conversation. I was on the podcast and have a conversation as well. So maybe before we kind of jump onto the whole space about software signing and stuff, what's the software supply chain and why is it important these days?
That's a good question. So consider any sort of supply chain. Okay, so let's look at automobile manufacturing, cars. Okay, so you'll have your final product of a car that is sold to a consumer. But if you look at that car, then all the parts of that car are sourced from different suppliers. Okay, so you have rubber manufacturers, you have a rubber plantation somewhere. You'll have people that design all of the circuitry, all of the embedded systems, all of these sort of brake monitoring systems, the engine, the iron, the steel, the aluminium. All of these parts are brought together to produce that final artifact, a car. Okay, so you have this supply chain, and they're all very reliant upon each other. There's I think they call it just-in-time manufacturing. So things have to arrive, and the production line has to move. Okay, so if we think of a software supply chain, it's very similar. Okay, so what you do is typically a modern piece of software will ingest other software systems. Typically, we'll call them libraries or modules, okay, to be able to allow them to build their software. Okay, these dependencies is another name that we commonly use. So you have this source of developers, this kind of ecosystem of developers that all work on different projects, and then ultimately those will all be brought together into a single software project. Okay,
Right.
and then that software will typically need to be in some sort of format that it can be released for an end user. So that's where you start to build container images, or you start to compile binaries and so forth. So you start to see how you've got this sort of supply chain. Okay, and then there's other things. There's various sort of actors that are involved in the supply chain. So just as we get the guy that supplies the rubber for the tires, okay, and then the person that makes the tires, within a supply chain, we have both humans and machines as well. So you have what we call build servers, okay, Docker OCI registries, and GitHub Actions and Travis and Jenkins. There's all these machines, and there's humans as well. So you have developers that write the code, and then you have people that review that code. So you have more humans that are involved, and so that is the software supply chain. Essentially, it's this orchestration of all these components to ultimately produce an end product that is used by a user. So it's very similar to a traditional manufacturing supply chain in a lot of ways.
Right. So, I mean, I guess probably from an importance perspective, what are some of the common supply chain attacks? Because I feel like, to what you said, if it's a a culmination of so many different components that are brought together in a systematic way so that we can, do this magic software in front of us, just so that people have a bit more context, what are some of the common supply chain attacks that maybe in a Kubernetes context as well?
Yeah, so there's a multitude of attacks, and quite interestingly, if we go back to this analogy of machines and people, so the attack, the origin could be a human. Okay, so it could be somebody could compromise my account. They might somehow get access to, let's say, I have like an identity provider type service that I use. I'm not going to pick on Google, but let's use Google as an example. Okay,
sure.
If somebody compromised my Google account, then I might use single sign-on to get access to my GitHub account. Do you see what I mean? And then so somebody could compromise my identity, okay, and then they could backdoor code. So that's a sort of a human attack. Something else that we see start to happen a lot more recently is what we call protestware. So I'm a software maintainer. I maintain an open source library. Something annoys me politically, or I want to make a statement. So what I can do is I could compromise my own software so that it essentially is ingested by all these other systems, and then it causes resource draining of resources. It spikes the CPU up and memory, and we've seen people do that. Sometimes for understandable reasons to them, but it's the impact that it has on people that are, perhaps innocent to the cause that they're protesting, if you see what I mean. So humans can be compromised, and then machines can be compromised, build servers can be compromised. That's something that's quite often is, an access to a machine is compromised. Okay. Getting more into Kubernetes, a Kubernetes image or something like a Docker file could be compromised. That happened there was an attack. There's a piece of software called Codecov. Okay. Cov is short for coverage. So with Codecov, it will look at your code and it will somehow establish your test coverage. So when we write code for any software, but particularly Kubernetes, okay, you would make sure that the code you write has what we call unit testing. So we can make sure that if somebody makes a change, they don't break an existing piece of functionality. So this Codecov, it establishes what is your coverage for testing. Okay. And they had a Docker file, an image that was exploited, and they changed like this bash script, which uploads the results, and it started to leak secrets. Okay. And so then we're moving into protecting of secrets. Okay, so this is where people will use some form of token to access a system. Okay,
Yep.
and it's something quite widely that we use in CI. You'll generate a secret token, and if these are leaked into the hands of somebody that's malicious and doesn't have your best interest at heart, they can use that token for their own means, if you see what I mean.
Yeah.
So within Kubernetes, a lot of the attacks that we see are not so much around the periphery of build systems and people. It tends to be more the APIs that we have, because we run a lot of APIs in Kubernetes.
Right.
So there can be various attacks that can perform what we call a privilege escalation.
Yep.
Somebody could have a certain access control level, okay, a service account, and they're able to escalate. Another one is a denial of service. We see a lot of those. Okay, not many of them are exploitable. That's the difference. But we see a lot of attacks where somebody can just throw large data sets, extremely large YAML files at an API, and then the API will either become over constrained. It's not able to function properly because the CPU usage is peaked up to 99, 100%, or memory is flooded and so forth. Memory allocation is just completely maxed out. That's one of them. And there is also container escapes. That's another thing that can happen. So somebody's able to, getting a bit more rare here, somebody's able to escape the confines of the container and access the host. So if you think about Kubernetes, you'll have a host operating system, okay, and then containers will run on top of that host.
Yep.
And they have a level of security seclusion that's meant to be in place to separate the container from the host. Okay, we use things like C groups, and this is principle of namespaces, and but somebody's able to escape the container and access the host underneath. So that's a kind of a lot of the attacks that we see around Kubernetes. But to the kind of the wider supply chain attacks, yeah, it's lots of things. It can be typo squatting is one that we see quite often.
Right.
So somebody could have there might be a popular library in the Python ecosystem called widgets. Okay. And then somebody will perhaps change the I for a 1. So it looks like widgets. Okay. And then somebody will download the wrong one, which is compromised. And other things that happen is people will use, they will abandon packages, and then somebody will somehow manage to do a password reset on their account.
Right.
And compromise the package. People forget to renew domains, which are often used as a way of getting a password reset. So if I run my own email system, and I forget to renew my domain, somebody else will register it and then do a password reset request to the package provider's system, and then they manage to compromise the account. So there's a lot of different areas that a supply chain can be infiltrated.
So I think that kind of leads to a question, and I think similar question to what I was thinking about. Vineet has thought about this as well. So first of all, Vineet was basically really happy with the SCA description analogy that you used. That was good. He was asking a question around having vulnerability tools to scan Docker images before production deployment helps, or do you recommend some extra controls?
Yeah, I mean, anything extra is good. Okay, so definitely, yes. So to scan an image to see what's actually in there. Okay, what exploitable CVEs do you have? That's any extra security controls are all good, I would say. I think there is no silver bullet. Okay, there is no killer single application that can provide security. It's layers of security. I mean, there's this quite old security principle that we don't really say it so much now because network topologies have changed, but we used to say defense in depth. Okay, so you build multi-layers of defense. It comes originally from the military. If you had like somewhere where you had a gun, okay, a big gun, you would sort of put mines around the periphery and barbed wire, and then you would have folks on lookout with binoculars, and you protect that area. You see what I mean? You have
Oh,
layers
right.
of
Oh, is that
defense.
why they have mines? Because I've watched in movies, they have
Yeah,
the mine. I'm
yeah.
like, why do you have mines when you already have guns? But okay, to your point,
Sure,
it makes
yeah,
sense.
it's exactly it's if one system fails, you have another system. You see what I mean? So very much so. When I'm talking away today, if I don't mention vulnerability scanning, doesn't mean it's not important. It's these are all important. You know, the more layers of security you can have, the better. Definitely,
Yeah,
yeah.
yeah. That's awesome. Now, thank you for that. And hopefully that answers your question as well, Vineet.
Sure.
Feel free to ask me more questions if you want. I think we kind of explained the common supply chain attacks. We also spoke about, I guess, what it is. One more thing that I normally get asked by a lot of people is around the importance of it. And I think there's a whole conversation now that's brewing after the whole Log4j happened for a while, where, hey, how do I know what dependencies that I have are vulnerable, open source? And there was all these conversations about this. I guess having been a developer before, like you have had a career at least some years in as a developer, how would you explain the importance of software supply chain to someone on the other end? Because I think one of the struggles that a lot of security people have is to explain to a developer, hey, because you can't just slap log4j on people's face and go, well, this is the reason why you should have it. Like, why is it important? Like, you use the example of Codecov, which is great for coverage. Any developer out there, like, oh yeah, I want to know how much coverage that I have for the unit test that I'm running. How do you explain the software signing or software supply chain signing thing to people? I guess, why is it important for developers?
So would this be me convincing a developer, or like
Yeah, like
yeah,
from a
so,
security perspective, I mean, for people who are interested in SigStore, I guess, which is the service we're going to talk about, which is the
sure.
open source service that you have for signing. So, but my question is more around how do you normally explain to people why is it important? Like, I mean, like for the non-converted, I guess.
Sure. So I guess there's several avenues of approach there. The first one is that being on the end of a successful exploit hack is not pleasant at all. Okay, it's companies feel a lot of pain from this because it's their brand that's at stake here. Okay,
Yeah.
so if you have good security controls, you have a level of brand protection. Because if a company's hacked, it's not the end of it, but it's really not a good optic for you as a company,
Yep.
And if you happen to be the developer it's not about blaming people, but it's just not something that somebody wants to experience. Okay, there's that level. The other thing as well is security is not a difficult thing. Okay, so I always I think some developers just think that's just not my area. I just write APIs, or I just I'm a back-end engineer, I'm a front-end engineer. What I'd say to folks is it's really not difficult to apply security principles to what you do. Okay,
Yeah.
so you're not going to have to learn how to do complicated mathematical computations and write your own cryptography or anything close to that. It's about some core basics. Okay, and so I would say if you're a developer and you're interested in this, and it's very good for your knowledge as a developer to understand these things, and when you're writing your code, to have this as a context. But there's an organization called OWASP, OWASP.
Yep.
Okay. And forgive me, I can't remember what the words are for that, the acronym. I think it's
Open Web Application Security Protocol.
beautiful.
Project, sorry. Yeah.
Yeah, there you go. So they have this top 10 secure coding. I can't remember what they call it, but they'll essentially they'll outline the things as a developer that you need to be careful of. So there are things like unsanitized input.
Yep.
Okay, so when you're using a variable and you're pulling in that value from outside, can somebody exploit that? There's privilege escalations. They've got this really nice outline of SQL injections, typical attacks that happen quite often around some sort of web-facing application. So I would have a look at that, and you'd be surprised. This isn't really difficult stuff.
No.
It's all quite applicable, and it's very good for a developer to learn this as your growth as an engineer.
Yeah, and maybe for the leaders as well, because I think a lot of we have a lot of leaders who listen to the conversation as well that we have here,
Sure.
and we can talk about Log4j and use those examples as well. But do you feel like from people who are security leaders, why they should start giving importance? And I think maybe Paraf, we can probably add the part of what the whole signing service thing is as well, so people understand the context for how to explain this to like a non-technical leader, if that's the word.
Sure. Yeah. So I think for the leaders that the previous point is probably even more prudent, which is brand protection. Okay. And I mean, when an exploit happens, it's no good to retrospectively fit security. Okay. So one thing that is very common is you can, if somebody asks when should I get started on securing my software supply chain, I would say last Tuesday. So you should endeavor to get into good habits as soon as possible. Okay. And and that way you preemptively start to embed the culture into your engineering teams around secure development. Your admins understand how to have secure systems. Do you see what I mean? And you can start to look at things like SLSA with the SLSA levels. Okay, so SLSA it's a framework of standards for improving the security of your software supply chain. Okay. And you can kind of step up in levels. So the sooner you embed this culture, the easier it will be to have a good, robust security posture going forward. If you see what I mean, these things will become an intrinsic part of what you do, as an engineering team and how you function. So I would say don't be scared, get jumping in early. And so around you were saying around sign-in and so forth.
Software signing. Like I said, what's the importance of the service in today's day and age for people who consider supply chain as a challenge or a problem?
Sure. Okay. So software sign-in is essentially so kind of just to get everybody up onto this level playing field. Cryptography, modern key technologies, okay, is you have what we call a key pair. Okay, so you have a private key and a public key. Okay, and you can use these keys to encrypt content. Okay, and then anybody that has the public key can verify that it's you that encrypted or signed anything. It could be it could be a tarball or a PDF, a container. Okay. So you have this key pair, and you can encrypt something or you can sign something. Now we're looking at the sign-in side. Okay. And what that allows you to do is verify that nobody's tampered with the object that's been signed. Okay. So I could take anything. Let's use the example of a PDF. I could sign that using my key pair. I could give my public key to you, Ashish. I could send you that file. I could put it on the internet on a, like some website, and then you can receive that file, and then you can use my public key to verify that it's not been tampered with, and then it was actually me. I was the identity that signed that PDF file. So that's something we call non-repudiation. It can't be disputed that I signed that particular PDF file. Okay. And then the safe transit of that we call integrity. Okay. So we ensure that not a single bit of that file has changed. So nobody's managed to put some sort of weird PDF abode vulnerability in there, or, so it's very much, you get those guarantees of non-repudiation and integrity. Okay. And that's where software signing is immensely useful for the software supply chain. Because if we look at that earlier example that we gave of code and artifacts moving along the chain to the end user, you can see multiple machines and humans are all interacting with your code and the artifacts that you produce. So if we bring it back to Kube World, a container, Okay, so what you can then do is using cryptography, key cryptography, you can verify who this thing is coming from. So for each stage of the chain, we can have an expectation that this machine with this key pair or this human with this key pair would have signed this artifact. So I know nobody's tampered with a tiny little bit of it. And I know who it's coming from. So there's non-repudiation. So if you gave me something that's full of malware, I'd know, well, hey, Ashish signed this, you signed this, you can't, there's non-repudiation, if you see what I mean. So then that way you've got a nice level of transparency around who has interacted with what and the integrity of that. Okay. And that's what SigStore is all based on, essentially, is the signing of things and making that easier. Okay. So I'll start to really dig into SigStore now. Okay. So traditionally with software signing or signing of anything, okay, it's the tools that we predominantly used are very old. Okay, we're talking, I might be wrong here, somebody could fact check me, but we're talking sort of 25 odd years is when GPG was originally developed. Okay, the first versions of it, and the protocol was designed. I might have got that wrong, so somebody's welcome to sort of.
It's really old. I mean, I definitely agree. It's been there for a long time.
Yeah, and it was amazing for its time. It was groundbreaking. So I would never in any way speak badly of GPG, but it was designed when things were very different. Okay, we did not live in the current paradigm that we have now of many systems all connected together and reliant upon each other. Okay, GPG was a bit more one-to-one in a lot of ways. Okay, and and to establish a trust circle with GPG, you'd use something called a web of trust, it would be called. And these would typically be set up by people would meet in person to sign each other's keys. Okay. And not to say that that's essential, but there was no trust authority unless you established one yourself. Okay.
Right.
And so as a result, what we noticed, so we started to look at software supply chain really start to get some attention about 2 years back, maybe 2-3 years. Okay. Really started to come under the microscope. And so when we looked at the wide open source ecosystem, okay, so let's say, for example, we have Python, they have PyPy. Okay. You have Ruby gems. Okay. For the Ruby world. Okay. And then there's Maven. Okay. And there's these different sort of packaging ecosystems. Okay. And then within Kubernetes, we have container images. Okay, so when we looked at the adoption signing, if a community actually introduced the code so that developers could sign things, generally the adoption rate would be around 2 to 3%, very low. So it might start off with people trying it, but they would just eventually fall away. Okay. And then the actual people verifying were even less. Okay. So we had a look at why that was. And it was generally because the tooling was cumbersome to use. Okay. The UX was just less than desirable. Now, I say that there's probably some security geek out there that's had a YubiKey for years, and they're absolutely fine doing that. And I would say, wonderful, that's great. But you are not the majority. You're the outlier. You're the kind of the 1-2%. Do you see what I mean?
People want the easy way out. No one wants to be putting YubiKey every day. I mean, to your point, no hate against people using YubiKey, but people just want an easier way.
That's it. And so most people do find this a challenge. They're thinking, oh, if I generate a key pair, okay. So these could be very smart engineers. Okay.
Yeah.
I generate these cryptographic keys. Where do I keep them? Do I keep them on my laptop? Okay. If I want to sort of use a different machine, should I put them on a USB key, like a dongle, and just swap it between machines? I accidentally checked my key into my GitHub repo. So how do I erase that now? Do I just sort of make another commit, but it's in the commit history? They have lots of fears. What happens if my laptop's stolen? How do I tell everybody, and it's embarrassing to tell everybody, hey, my private key, I left my laptop on the train, and so generally people were just apprehensive to get involved, and we realized this was because of the UX. Okay.
Oh,
So
right.
if we were going to solve this, we had to make it easy for developers to use. Okay. To use cryptography to sign things. That has to be a simple UX. Okay.
Yeah.
And so we looked around for sort of other scenarios that had played out where a technology that was cumbersome was improved with a UX. Okay. And a great example here was Let's Encrypt. Okay. Now, if you look at if we go all the way back to 2014.
Yeah.
Which seems recent, but I guess that's
I know, like COVID kind of made a lot of things happen very quickly.
8 years ago now.
Yeah.
And if we look back to around that time, so pre-Let's Encrypt,
yeah,
probably 2013. Let's Encrypt, I think, started 2014 around that time.
Actually, maybe what is Let's Encrypt for people who have some context?
Yeah,
I
that's
know what it is.
Good example. Yeah. Okay. So Let's Encrypt. What Let's Encrypt do is when you visit a website, okay, you will see the URL prefix has HTTP or HTTPS. Okay. So the S denotes secure. So it's using this cryptographic key system that we described earlier. Okay.
Yeah.
And so when you visit the site and you see HTTPS and a green padlock, that generally means that your connection is secured with cryptography. Okay.
Yep.
And it is also the website that you expect to be talking to is the website that you are actually talking to. Now, there are little caveats to that. Okay. There are little kind of, attacks and so forth, DNS exploits and stuff. But generally, if I go to bankofamerica.com and I see that green padlock, then I know somebody, an authority, is communicating to me that this is I'm vouching that this is the bankofamerica.com. Okay.
Right.
Now, what Let's Encrypt did. So previous to Let's Encrypt, if I set up a website because I don't know, I like collecting model trains or something like that. Okay. So I install a WordPress site on some hosting platform. Okay.
Yep.
If I want to run HTTPS, what I would have to do is I'd have to contact a provider. Okay. And they would require me to generate some keys and some certificate signing requests. So right away, I have to work out, my gosh, what are the OpenSSL commands? So I'm going to get on Google and I'm going to Google, how do I generate certificates for, and I don't know anything about RSA or ECDSA or any of that, but, there's all these terms. So I have to work out how to run those. Okay.
Yeah. Then
I need to pay them. So I got to get my credit card. If I've got a credit card, what if I'm a 14-year-old developer from London or Bangalore or Sydney, or do you see what I mean?
Yeah.
So I have to pay them, and then I've got to send them this stuff. Okay. And then I have to kind of like go through a challenge sequence so they can make sure who I am. And then they'll send me back a zip bundle. And then I'll be like, right, how do I get this to work in Apache? So now I'm back to Googling stuff. Do you see what I mean? And I've spent maybe a whole day doing this. Do you see
I remember the pain of self-signed certificates used to be a thing.
Exactly, yeah. And then you get a year later and you've got to do it all again.
Yep.
So it was, the tooling was just not a good UX. Again, you got your security geeks. We're not talking to you folks now. We're talking to the majority. The UX was poor. Do you see what I mean? And there was cost to it as well. Okay. So Let's Encrypt came along and they said, let's make it free for everybody. You can get certificates for free. And then we will produce tooling and infrastructure services to help automate this. So they came up with CertBot. So now with Let's Encrypt, you can just set up a cron job. A command line thing runs called CertBot. And, it will even set up Apache and Nginx for you. It will do all of that. Do you see what I mean? You just need to do an initial setup, and when it comes to renewing, you can just automatically renew. incredibly easy. So what happened was again, I'm probably going to get my figures wrong here, but HTTPS usage was around 30%. Okay.
Yeah.
And then after Let's Encrypt got traction and established, it went up to 70%. Okay.
Wow.
And the result of that is it made a safer internet for everybody.
Yeah. Yeah.
So SigStore really is kind of borrowing the trajectory that hopes to replicate the trajectory that Let's Encrypt had. So we have this saying in SigStore, to be to the software supply chain what Let's Encrypt was to HTTPS. Okay.
All right.
So that essentially everybody has the tooling to make it easy to sign things. Okay. Now,
Right. And this is a free project as well, right? This is
it's a
the
free
same as
project.
Let's
Yeah,
Encrypt.
yeah. And there's one I just wanted to touch back on the Let's Encrypt thing. So what happened was when that proliferation of HTTPS skyrocketed up to 70%,
Yeah.
it then became socially unacceptable to run a website on HTTP. Okay. So even the browsers started to circle around HTTP. So where we are now is if you go to a website and you put in HTTP, ilikemodeltrains.com. Okay,
Yeah.
it kind of feels like, this doesn't feel good. It doesn't feel safe. Do you see what I mean? You're not going to want to sign up to that website, let alone put your credit card in there. So generally it's now what they've managed to do is they got the mass adoption, and the perception has changed now where the expectation is everything should run HTTPS. It should be TLS everywhere. That is how it should be. And the users expect that now. So what we want to do is do the same for software. Okay. So we get to the point that if somebody ingests something on the supply chain, okay, whatever that might be, a dependency or a container, if it's not signed using cryptography technology, it kind of feels a bit, I don't feel comfortable with this. I don't want to trust this. Do you see what I mean?
Yeah.
Dan Lawrence makes a really good analogy here, which is that when you run get package from some open source package managers, it's similar to picking up a USB key off the floor and just sticking it in your laptop. The risk levels are the same. Okay.
Mm-hmm.
And so for SigStore, we hope to change the paradigm. Okay. So the expectations are signed by default and everything should be signed. And if it's not, you cannot trust it. Okay. And so, with SigStore itself, it's a group of open source projects. Okay.
Right.
So it's a multi-vendor effort. Okay. There's no single company that's behind SigStore. Okay. And we all write the code in the community and the documentation for SigStore. Okay.
Right.
And SigStore consists of services that we run. So we run some infrastructure to do things such as to provide the certificates. Okay. And we have something called a transparency log. I won't deep dive into that too much, but it's a kind of a blockchain technology.
Right. Okay.
It means things are transparent and open. So you can see exactly who's been assigned what certificates to sign what artifacts. So you've got this kind of open bookkeeping system, which is built upon cryptography. So it can't be tampered or changed to cover up some sort of bad action. You see what I mean?
Yeah.
So we have these services that we run. Okay. And then at the same time, we also develop clients. And the clients are the tools that sign an artifact or some code specific to that language or that ecosystem. So one of the ones that we have that's most well known is called Cosign. Okay.
Oh, yeah.
And Cosign is actually container signing. Okay. And with Cosign, you can sign a container image using SigStore. So you can use the SigStore infrastructure and the Cosign tool to sign a container for free. Okay. So you'll get a free software signing certificate to sign your container image. Okay.
Wait, so can I have it behind my firewall as well then? As in, it's not to your point, because a lot of people think HTTPS, it has to be always internet facing. So you're saying that SigStore as an open source project, like, the example that I was giving of self-signed certificate.
Sure.
So this can still work with behind the scene as well for personal use, as in.
Yeah, very much. Yeah. So Cosign will work with private registries, ACI registries. Okay.
Nice.
But you can, in fact, so with SigStore, we call it the public good service. Okay. So we run this free to use, publicly open service that anybody can use. Okay.
Yeah.
But the technology that we run to provide those services, that infrastructure, you can deploy that yourself within your own network. Okay, so if I was speaking to, there's kind of a senior IT leader that has works for a company and they need to implement something similar internally, then you can set up your own SigStore. You can have your own trust route. Do you see what I mean? And you don't need the public service. So that is quite possible. And you can sign your own container images then, and you can use the public service for if you pull a container image from outside of your organization. If that's signed with Cosign, then you can verify the source of that container image and that it's not being tampered with, essentially. You get guarantees around the tamper-free structure of that container image.
Right. But you know how when we were talking about the whole non-repudiation earlier as well.
Mm.
So how does that cover with knowing that, oh, this is Luke who signed it versus Ashish who signed it? Like, is that how does it verify that part?
Right. That's a really good question. So what we do in SigStore, okay, is so if we go back to this concept of keys again, okay, typically you'll generate a key pair and they're termed long-lived. Okay, you'll keep them for, you know, however long you set the expiry for. But people tend to do 365 days. Again, I say that somebody's probably going to say, no, that's wrong. It should be 180 but that's generally the amount that people go for. Some people go for more. Okay.
Yeah.
And those are long-term keys. Now, most of the time, like in a corporate environment, they will have specialist hardware that will store that key. Okay. Now, as said earlier, we realized this was problematic for a lot of users. So we utilize some other protocols, security protocols, to allow us to have, we call this technology keyless, okay, where you do not need to manage a long-term private key. Okay, so I'll probably get a little bit hand wavy here, but we use something called OpenID Connect. Which is a protocol that's part of OAuth 2 specifically. Okay. And what you're able to do is you can sign a container image with an open identity based account. So Google, GitHub run a style of IDP. We call it an IDP, an identity provider. Okay. Microsoft, there's many. You can even run your own one privately. Okay. And what we do is we have this kind of clever switcheroo, okay, where the client will connect to our public infrastructure, okay, and it will request a sign-in certificate. What we do then is we present them with a page. Okay, we open a browser where you can then, you know, where you see sign in with Google. You will then click sign in with Google, okay, and then our system will then go off to talk to Google and we'll say, hey, this user's authorized us to request from you something called a scope. Okay? Now, a scope is pretty simple. You would have come across them a lot. A scope, if we use Google as an example, a scope could be access to your calendar, because I want to make entries in your calendar. Access to your drive, because I want to back stuff up to your drive. Access to your email. Okay. What we do is we ask for the user's email address, and that is all. So we get back lukehinds@gmail.com from Google. Okay. So then that way we know that whoever has initiated this signing system is in control of this account. Okay. And then with these accounts, you get lots of nice extra security extras, like two-factor authentication to protect the accounts and so forth. Okay. So we now know that whoever's signing is in charge of this account. They're logged into this account. So when we provide you with a software signing certificate, we will put the email address into that cryptographic certificate, which is signed by our main certificate root that we have in SigStore. Okay.
Yep.
And then you can then sign your container image. Okay. And then that then goes into this technology that I described earlier called a transparency log. So you can think of it like a blockchain. When something's in there, you can't change it. So we put that transaction into the transparency log. And then immediately afterwards, you can discard the private key. You don't need to keep it because we've frozen in time that moment where you proved that you're in control of an account.
Yep.
You had a temporary key pair. We provided you with a software signing certificate and you signed a container. So at a latter point, somebody can then verify that Luke Hinds at gmail.com signed a container image. Okay. So they can know that I or whoever was in charge of my account signed a container image. Okay. So then you can do things such as you could say, if a container image is signed by Luke, I'll let it run in staging, but I'm not going to let it run in production until Ashish has signed it. Okay. Mm-hmm. And you can build up a policy. So now what we have in Kubernetes there's these things called admission controllers. Okay. And an admission controller will basically red or green light a workload running on Kubernetes. Okay, based on whatever logic you develop specific for that admission controller. So we have admission controllers that will look for a SigStore signature, something that's signed by cosign. Okay.
Right.
And an admission controller could say, I'm not going to allow this pod to instantiate until I know it's been signed by Ashish. Mm-hmm. You know what I mean? Or signed by Luke. So you can build up policy then around something being signed. So you know the source of where it's coming from. Okay. And we do other things as well. So you don't just have to sign it with your Gmail account. Okay. So in the context of GitHub, they run an OIDC. So you can get guarantees that a container was built within a certain GitHub repository. Okay.
Oh, wow.
All of that stuff is put into the certificate. So you have source origin then. You can see where a container image was built. And we do the same thing with Tekton. So folks that are using Kubernetes native Tekton, there's a project called Chains. So when Chains builds a container image, okay, a pipeline is executed. Then that image can be signed by that machine. Okay. And there's many other things as well. We work with Spiffy as well, Spiffy and Spire. So that can interact with SigStore around the signing of things and establishing of trust and so forth. So SigStore's become very multi-embedded into the Kubernetes ecosystem. There are other folks using SigStore to sign CRDs. So you have a CRD where you describe your deployment, your Kubernetes deployment. You can sign that, and then an admission controller can check that that's been signed before it's allowed to run on your cluster. If you see what I mean?
Like an artifact signing. Okay.
Yeah, very much. Yeah. You effectively sign the YAML.
Yeah, fair enough. Wow.
So that way you know that if somebody managed to tamper with a bit of YAML somehow, I don't know, they got access to a system somewhere and they changed an API, slightly changed the IP address or did something to possibly exploit a system, you would know because it would break the integrity of that signature. Okay.
That is pretty awesome. So I in my mind, I'm thinking like a good use case already is the fact that if you're using SigStore, having the signing, you almost are building like a chain of custody for like from the point of origin of GitHub all the way to this is our GitHub organization, whatever XYZ. And Ashish kicked off a process to use a container which is produced by the YAML in that GitHub repository. And then I send to Luke to approve it. And then it goes into production.
Exactly, yeah. And then if we consider where we kicked off the conversation around the supply chain, humans and machines all interacting with things, then we have that chain of provenance.
Okay?
And that's right. What SigStore helps to happen, because there are other things as well. People start to hear the term SBOM. and attestations, SLSA
Yeah.
attestations. Okay, and an SBOM is essentially, think of it like a recipe of the supply chain. So if I have chocolate cake, okay, that chocolate cake required chocolate, flour, sugar, milk. I'm not very good at baking, but I believe those are the
I'm good at eating though.
yeah. So you could then an SBOM could describe the chocolate. I got that from Walmart. Okay,
Yep.
the flour was from here. It was originally milled in, I don't know, some country. Okay, and then it was put on this ship and it went to there, and you
Anyway,
get to see all
made
the
it to our door, yes.
intermediaries. So an SBOM seeks to do the same with software. What are the dependencies that were ingested to build this software? Okay, and with the more kind of attestation based. So these aren't really so this is where we start to get into labels. SLSA uses a project called Entoto, okay, and it has attestations, and that has lots of cryptographic guarantees built in there, like a digest of the particular artifact that you're interacting with. So what we can do with a SBOM and Entoto style attestations, SLSA attestations, we can start to record all of the steps, and the individuals and the machines can start to cryptographically sign off to the next person or machine. And they can verify that who they're receiving it from is the person that is authorized to do that. Okay. And we build that trust system on cryptography. Okay. And SigStore is able to really nicely interact with these components and look after the sign-in side. So you haven't got to have these long-term keys, and you can kind of start to automate things using SigStore tooling.
Awesome. Wait, so I mean, it sounds like there are a lot of awesome use cases from a business perspective for SigStore. I'm almost wondering, because you know how a lot of us have been doing this for a long time. Like, I mean, I've created a lot of self-signed certificates for a long time as well.
Sure.
As people are kind of going into that journey of using, say, something like SigStore to sign containers for now, and hopefully a lot more as they kind of progress and mature, what do you see people do as a, I guess, you know, they've heard you talk like software signing is the future. Yes, I'm going to contribute to that growing chart. Where does one start from a maturity perspective? What would day one, or what can day one look like? And then, I don't know, day 365, when you've done across all the board at scale, how does it work in a scale comparative? I mean, I guess, because I mean, enterprises have a lot of applications to manage and look after.
Sure. Yeah, sure. So interestingly, so okay, if somebody wants to get started day one, okay, I would recommend SLSA as the source that they go to. So SLSA is very good with these. It has this stepped approach, these levels. So level one for SLSA, I believe, if I recall correctly, it's like you should have some sort of, your build system should be scripted, okay, and you should produce some level of provenance, an SBOM. So that gets you to step one. You don't have to sign it, okay. That comes in step two. So step two, you need to start having signatures, okay.
Right.
And then level 3, 4, it starts to become, the controls become tighter. You have hermetic builds, reproducible builds, all of these sorts of elements start to come in. So SLSA is a very good map, really, to improving your supply chain. Now, when it comes to at scale, you know, multi-site, multi-data center,
multi-cluster as well.
Multi-cluster, yeah. It's we've made good progress in SigStore, okay, and because I think the good thing that we did was we built the systems from the beginning to be conducive to those environments, if you see what I mean. So, but it is stuff that we're working on improving at the same time, is, you know, running at large scale as well. So I guess we're about just over 2 years old now, the project.
Wow.
And,
wow. This is 2 years old.
Yeah, it's been absolutely incredible, the speed that things have moved at, very much. Yeah. So I mean, since we've launched, we've a lot of Kubernetes release images are all signed with SigStore. So they've sort of standardized onto SigStore. And we have organizations such as GitHub are looking to introduce SigStore for signing of NPM. We have the Maven community who are looking to do the same. So there's lots of open source communities, the Python community, who are looking to onboard SigStore as this means of generating signed provenance within their ecosystem. So yeah, a lot has happened in the past couple of years, and
yeah. So it's not just Kubernetes; you can do it for anything, any
yeah,
software.
very much. Yeah. I mean, we are kind of the Kubernetes cloud native system have been very good. They've helped carry us up. We've rode a wave on the CNCF type technology. Okay.
Yeah.
But the big picture has always been that SigStore is much bigger than that. Do you see what I mean? So
yeah.
We have libraries for Rust. We have libraries for JavaScript, for Ruby Gems. So the folks at Spotify were looking at introducing this for Ruby Gems. There is work looking at using SigStore for signing machine attestations as well, and all sorts of interesting stuff. So as I say, we've got a lot of success, and we're grateful to what the cloud native world has done. But yeah, SigStore should be have a much larger area of impact than just that ecosystem. That's what we hope.
That's pretty awesome. I think after listening to all the analogies that you've shared and what we are talking about as well, kind of agree with what Vinny said here. If Luke plans to start a Kubernetes security training, I'm happy to join his training. Great explanation.
Thank you.
Yeah. So I kind of agree with it. I love the analogy so far as well, and how you kind of mapped it back to like the basics as well.
Sure.
I mean, that's kind of what we had time from a technical perspective, but I've got three questions that I normally ask from a fun section perspective for people to get to hear a bit about who Luke is as well. The first one being, what do you spend most time on when you're not doing SigStore and everything, I guess?
Yeah, okay. So I have a young family. I try to spend time with them. So I try to divide my time equally between work, family, and a bit of time for me. So meantime is I'm quite an avid runner. I'm not elite by any means, but I run quite a lot, and I like to run these races that we call ultra marathons. So I spend a lot of time. Yeah, I spend a lot of time sort of training really. So my typical day is get up about 5 a.m., pull on my trainers, go out, run for a couple of hours, come back, get the kids ready, start work. And then on the weekend, I have to balance it, because otherwise my wife will be like, we need to have a conversation about this. So, but yeah, I'm absolutely, I love running. I can talk about running the same way I can secure supply chains. So, but I don't get invited to talk about running much.
We should definitely put you on like a running podcast as well. That would be pretty awesome as well. That would be fun. So the next question that I have is, what is something that you're proud of but is not on your social media?
Sorry, proud of, but
something that you're proud of that is not on your social media.
Oh, that's an incredibly good question. I guess my children. I don't know. That's an acceptable answer.
Yeah, no, that's. I mean, family and children.
It's, I don't think I'm necessarily. They're individuals. They've cultivated themselves, but got two wonderful daughters. And yeah, I guess, that would be the main thing that I'm proud of. Yeah,
you can definitely play this back to them on their birthday.
Yeah.
See
I should have my wife as well, just in case she listens in. I'm very proud of my wife as well. Yeah.
Oh, there you go. The entire family.
Sure. Yeah.
So last question. What is your favorite cuisine or restaurant that you can share?
Oh, okay. So I love all sorts. Okay. I mean, that's the one thing. England's not known for having any sort of unique cuisine, but the great thing is it's a melting pot. So there's so many different good types of food. But I think what I love, and this is going to sound probably kind of quite obvious for an Englishman, but near me, so I live in the West Country, okay, the Southwest, quite far away from London. It's quite rural, and it's mainly farmers and software engineers, remote software engineers. And there's a town city near me that's quite well known called Bath, and there's a place there called the Scallop Shell, and they do the best fish and chips in the universe. They are amazing. Like they get fresh catch every day, and just it is incredible. They've won awards for being the best in the UK. So I do love to go there. But I mean, I love Thai, Indian, Italian, all sorts of food. I'm getting hungry just thinking about it.
Yeah, I was gonna say it's almost like your breakfast time and my dinner time as well. But no, Luke, was awesome. Thank you so much for
Sure.
this.
Oh no,
Thank you for
thank
the
you so
answers
much
as
for having
well.
me.
Yeah,
Yeah.
and it's been a great session. I kind of agree with all the sentiment being shared in the chat messages as well. And where can people find you to know more about you and what you do in the SigStore and otherwise cloud native space?
Sure, yeah. So I've got my Twitter account tagged there, Decode Bytes. So anybody's
Yep.
welcome to send me a direct message, and you can reach me through there. I'm on various Slack channels as well, so I'm always happy to talk to people on there, and that's the best way to reach out to me.
Awesome. I will make sure I put that in the show notes as well. But thank you so much for this. And
Okay.
I'm looking forward to when we have the next version of SigStore when it's being used globally, not just for
Yeah,
Kubernetes, but for a lot more things.
yeah, I'd love to come back.
Yeah. Awesome. Now, thanks so much for
Great.
this. And thank you everyone for tuning in. We'll be back with another episode of Kubernetes Security next weekend as well. So I'll see you on the next episode. Thanks, Luke. And